Picture an incoming email containing a standard HTML attachment. The secure email gateway scans it, sees only harmless text/HTML tags, and clears it for delivery. The user opens that file in their browser. Exactly 2 seconds later, a malicious ISO file drops onto their desktop. The security team pulls the gateway logs, expecting to find the external download request. The logs are empty. The payload never crossed the wire as a recognizable file. Imagine a customs checkpoint searching for smuggled weapons. Instead of trying to hide a fully assembled rifle in a suitcase, the adversary sends a blank piece of paper containing origami instructions. The checkpoint clears the paper. Once inside the perimeter, the target's own hands, or in this case their local browser, reads the instructions and folds the paper into the weapon. HTML smuggling turns the endpoint's legitimate rendering engine into a malware delivery vehicle, bypassing perimeter network defenses entirely. Standard network inspection tools fail against this technique for 4 structural reasons. First, this animated diagram shows an HTML envelope traversing the network. Inside it is a compressed string of text, which easily bypasses a firewall looking for traditional zip signatures. Second, the transit of this HTML page is obscured by TLS encryption, completely blinding the scanner to its contents. Third, there is a MIME-type mismatch. Gateways are programmed to hunt for executables or application/zip files, so they ignore the text/HTML tag on the envelope and pass it through. Fourth, by generating a local Blob URL inside the browser, the dropped file can evade mark-of-the-web security tagging on legacy Windows builds. Microsoft has since patched many of these mark-of-the-web bypass pathways, but the structural invisibility on the network remains fully intact. This evasion relies entirely on the deliberate exploitation of how the internet handles encrypted traffic and basic file types. To identify this assembly mechanism, an analyst must recognize 3 core JavaScript APIs hidden inside the HTML code. It starts with the atob function. This node graph shows atob decoding embedded base64 text into raw bytes. Next, the Blob API takes those blocks, constructing an in-memory file object. Third, URL.createObjectURL generates a temporary URL prefixed with Blob, pointing directly to that hovering object. With the URL established, the script programmatically creates an HTML anchor element, assigns it the Blob URL, and tags it with a download attribute carrying the chosen file name. Finally, the script executes a hidden click command on that anchor, forcing the browser to drop the file to the disk automatically. In some samples, you will see msSaveBlob instead of these standard APIs. That indicates a campaign specifically targeting older enterprise environments, running Internet Explorer or Legacy Edge. By weaponizing these built-in APIs, the attacker perfectly mimics a user-initiated file download without making a single outbound HTTP request. The threat actor NOBELIUM refined this structural evasion template in their spear phishing operations throughout early 2021. NOBELIUM is the highly advanced group responsible for the Sunburst backdoor that compromised the SolarWinds Orion platform. In May 2021, they escalated their delivery operations by hijacking the legitimate mass mailing service Constant Contact. They spoofed a US-based development organization, USAID, to distribute malicious links to thousands of targets across multiple industries. When a target clicked the link in the email, the URL directed them to the legitimate Constant Contact service, which immediately redirected them to NOBELIUM-controlled infrastructure. That infrastructure served an HTML smuggling document designed to execute the local payload assembly we just outlined. This flowchart shows the resulting execution chain. The HTML document drops an ISO container, mounted as an external drive. Hidden inside is a shortcut file, which executes an accompanying DLL. This sideloading step drops a custom Cobalt Strike beacon, granting the attackers persistent access. This specific sequence of HTML to ISO to LNK became the definitive delivery template, copied extensively by subsequent threat actors. When you are tasked with dissecting a smuggled payload, the absolute rule is to never open a suspicious HTML file in a browser. Your first step is to open the file in a text editor. You are hunting for the atob, blob, and createObjectURL JavaScript primitives, or a massive block of base64 text. Once you locate the base64 block, copy it into a decoding tool like CyberChef. Apply the from base64 operation. If the decoding is successful, you will identify the magic bytes of the embedded file. If the output reads as garbage, the payload has a secondary layer of encoding. Review the JavaScript logic for XOR or Caesar cipher transformations applied right before the atob call. The final extracted output, whether it's an ISO, a zip, or an executable, will dictate your next specialized analysis path. Documenting this full chain is critical, as HTML smuggling is almost always the initial access link in a much longer attack path. Because network visibility is entirely neutralized by this evasion technique, your defense strategy must pivot to the endpoint. Endpoint detection and response telemetry must be configured to flag anomalous browser behavior, specifically the creation of a blob URL followed by an immediate automated file write. On the email front, deploy Yara rules designed to match the atob, blob, and createObjectURL strings directly within HTML attachments to catch commodity kit samples. Downstream of the download, Microsoft Defender's attack surface reduction rules provide critical preventative enforcement. Specifically, you must enable the ASR rule that blocks JavaScript or VBS script from launching downloaded executable content. The payload is never on the wire. The browser simply reads the benign instructions inside the envelope and locally assembles the weapon. Mastering the mechanics of this technique separates standard operators from engineers who understand the true architecture of evasion. Head to learn.epoch0.net for further REMA training.